All right, good afternoon. This is Pilo Pierce. I'm one of the vice presidents of Eduporium. I wanted to welcome you to one of our fifth webinar series events. The focus today is what's new with MakerBot's 3D printers, and we'll have a quick discussion about that. I want to introduce, my role is to manage sales and marketing at Eduporium, and one of the things we focus as an organization is focusing on closing the gap in 21st century education by accessing and allowing quicker and more access to vetted, innovative STEM educational technology. And so think of us as a one-stop shop for educational technology. One of the things we provide is we'll work with you on your educational vision, making sure the products, whether it's 3D printers from MakerBot or some robots or what have you for your different programs. So I'm pleased today to have, I would encourage everybody, if you have questions or chats or anything like that, please put them in. And during the conversation with Crystal and Patrick, I'll make sure to get those on the table so that they answer it. We're pleased today to have the MakerBot team with us today, the marketing team with us. We have Crystal Hale, she's a marketing manager for MakerBot. And we also have Patrick Mulchrone, who is another marketing manager. And the two of them will cover, give us an update on MakerBot. And they'll also talk a little bit about how to use MakerBot products in a remote environment or hybrid environment, not only in a classroom environment. So we find that these work well with a lot of questions and things like that. I think it stimulates ideas. And we're hoping that you go away with one concept or something new that you've learned today. So with that, I'm going to turn it over to Crystal, and Crystal will kick us off. I do want to welcome everybody and thank you for attending today. We'll keep to the clock and make sure that we get you in and out of here. We know you're very, very busy. So with that, Crystal, I'll hand it over to you.
All right. Okay, I think everybody can see my screen. So thanks so much for having us today, guys, and for joining. We're excited to be here talking with you guys about MakerBot and education. So as Payla mentioned, my name is Crystal Hale. I'm going to kind of start out giving you some high level, and then I will pass it over to Pat, who will get into some of the nitty gritty and share with you guys some of the printers that we have and how they're targeted towards education, as well as what we're doing, as Payla mentioned, to support hybrid learning environments in the midst of how education has changed over the past year. So I always like to use this slide just to kind of kick off and get us started. And normally I'm like talking to people who can actually talk back. So I know you guys have chat and it's kind of a giveaway, so I won't require participation, but what do all these things on this slide have in common? And you may have probably guessed, seeing as how Pat and I are here to talk to you today about 3D printing, but they were all made on some type of 3D printer. Now, I want to preface this, not a MakerBot, okay? We're not printing houses over here, but these things were 3D printed with some form of 3D printing. And so I think that's so important for us who are focused on the education community, especially to think about, 3D printing seems like it's still this new, exciting thing, and it is, but it is already so relevant in so many different fields today. So as I mentioned, here in the middle, we have a 3D printed home. This is a concrete 3D printed home that is in Mexico, and it is actually in a subdivision that is entirely 3D printed concrete homes. They find them to be more affordable. They're actually cooler, so better for the heat. And so that's a trend that's picking up. This is a pastry up at the top. So there are actually 3D printers that are designed for food. And we're seeing desserts being definitely the top market there, but that's something that's continually expanding as well. This is the Blade. This is a 3D printed car. So almost this entire vehicle was made with 3D printing. We're 3D printing metal now. It has custom rods that help it come together, this quick, sleek design. It's very light, very fast. Down at the bottom here on the left, this is an Adidas 3D printed shoe. This entire shoe is 3D printed, which is honestly a little bit extra, but we are seeing a lot of use cases, even in consumer goods, where they're 3D printing insoles and finding that they have more steps, better life. And so Adidas being one that's doing that. And so they kind of just wanted to 3D print an entire shoe as well. Down here, we have these rubbery brain implants. So brain implants are typically made from really rigid material that over time causes buildup of scar tissue and issues. And so there are these MIT engineers have figured out a way to develop this soft, durable, flexible implant, and it's 3D printed. Of course, here we've got prosthetics, which has been a big use case for 3D printing. And then down at the bottom middle there, I've never actually had anybody guess off the top of the head what that is, but that's actually 3D printed coral reef. So researchers at the University of Cambridge and UC San Diego have found a way to 3D print coral reef that actually possesses all the photosynthesis and bionic capabilities of algae. That's insane. So that's not going to replace our coral reefs, but it's taking us a huge step forward in trying to figure out how to save them. So I wanted to share that just to get you guys thinking. Once again, not done with MakerBot 3D printers necessarily, but just to show you how 3D printing is really touching so many different industries already. In 2019, over 50% of corporations in the US were using 3D printing to some capacity. So it's definitely not a fad. We're truly on the brink of the next industrial revolution with 3D printing. So we'll talk a little bit about who's using it, why MakerBot for education. As I mentioned, Pat's going to talk about our printers and then using those printers in a remote environment and in the educational settings that we're in today. So probably everybody knows, but just in case they don't, what is 3D printing? It is the process of taking a digital model and making it into a physical object. And so I actually have a couple things that I'll share that I've 3D printed. So I'll come back to that a little bit. But once again, why is this important? So to give you a little background on myself, I actually came to MakerBot from doing Google business development for Google for Education. And it was really surprising to me when I first came on board and I started putting together my decks, I came across this statistic, which is actually a statistic that Google has been using as well when we talk about Google for Education. And that's that 65% of children entering primary school today are ultimately going to end up working in jobs that don't even exist yet. So how are we preparing that future for them? How are we getting them the skills that they need to be successful in these industries as we continue to grow? And those are actually my two little nuggets. Those are my two little boys. That is my sketch printer that's here in the room with me. And they are 5 and almost 2 and just completely enthralled already with 3D printing. So as I mentioned, a lot of use cases, but just to give you some examples in the commercial industry where we're seeing a lot of traction and success, specifically with MakerBot as well. Any kind of product design, engineering, manufacturing, any kind of prototyping, 3D printing is so huge. I'll give you an example. Well, I'm gonna say that example. Just hold tight on that. I get excited. I get ahead of myself. Medical industry being huge. We saw the prosthetics earlier, dental impressions. They're actually doing surgical planning, 3D printing models for surgeons to practice complicated surgeries before actually executing them. So I don't know about you guys, but if I had to have a complicated surgery, that's probably something I would love for my surgeon to do. Since everybody's unique and every surgery is unique, giving them a way to really kind of practice before executing. Architecture, so 3D models and planning for architecture, huge use case. Entertainment, we've actually worked with a movie studio that has 3D printed an entire alien suit on our Z18 printer. So a lot of really interesting use cases, really just across the board. And then of course, education. So primary education and higher ed, and those skills will grow and develop, and what their 3D printing changes, you know, the more advanced that they get. And we'll talk a little bit more about that as well. So why MakerBot? Why MakerBot for your educational needs? So we are the #1 3D printer in education. And this slide is a really great synopsis of the reasons why. So I'll talk a little bit more detail in a couple slides on some of these, but we have the most comprehensive teacher training. We are the only 3D printer company that has ISTE certified educator training. So it's over 10 hours of ISTE approved content for teachers. I'm going to talk a little bit more in a second about our student certifications and our educator community as well. I'm going to talk a little bit more about that. but very, very easy to use, seamless integration with your classrooms. So we are a Google for Education partner. So we have a cloud platform now. You can be completely cloud with our printing. We integrate with Google Classroom. We also have, once again, our CloudPrint, so students can submit files both ways, and Pat's going to share a little bit more about that later on. So just really worry-free teaching, right, to help make the technology part of this is easy and seamless as it can be to integrate into current classroom setting. And then just incredibly easy to use hardware. So I'll share a personal story. I mentioned I came from Google Business Development. I was on the software side. I'm not gonna lie to you. I'm one of the least technical people you'll ever meet in your life. It astounds my family every day that I have somehow ended up in the IT industry at all. I mean, truly. And especially Google, like I started getting my feet wet with IT, but I was doing complete software. There was no hardware involved, right? And so I actually started with MakerBot in March at the start of the pandemic. And so I haven't gotten to even go into headquarters. Everything I've done has been from this room here. And so they were like, hey, we're going to send you out a sketch printer. And I was like, you really don't need to do that. That's not necessary. And they're like, no, we're going to ship it to you. It's going to be great. You're going to love it. And I'm like, oh my gosh, maybe I should have disclosed in the interview process. Like, I think 3D printing is going to change the world. It's incredible. I personally have no desire to 3D print anything. And they're like, no, but you're going to love it. And I'm like, I'm not very technical. I don't think. And they're like, promise you could do this. And I'm like, okay. I'm like, well, I'll have my husband help me set it up. And they're like, no, Crystal, you can do this. We want your feedback. We want to hear your experience. Like, don't let your husband help. Like, we're going to ship you a printer. And I'm thinking, oh my God, it's the middle of the pandemic. I just got this job. I'm about to get fired. Like, this is not going to go well. But no, they shipped me that printer. It literally, it comes out of the box assembled. You have to remove some packaging. And the instruction card that comes in it is like step 1, plug in printer. Step 2, turn on printer. Step 3, follow instructions on the printer. And on the little LCD screen, it walks you through exactly what you need to do to load the filament, to set everything up. And so it was incredibly easy. So when I tell you that if I can do it, literally anybody can do it. So let me see, I will stop sharing my screen just for a moment because I think that makes me a little bit bigger. And I do want to take a minute just to share with you guys some of the things that I have printed on my Sketch 3D printer. So maybe some of you guys have seen these. These are little ear savers. I show these because I started printing these and I actually did like a little LinkedIn post. And I started having all kinds of people who work in the medical field or who knew people who were essential workers who were working all the time, who'd been complaining that the masks were hurting the backs of their ears. And they were like, oh my gosh, can you ship me these? And so I actually started making them and shipping them out. But these are just the little ear savers that go on the back of your head that you can wrap your mask into to keep them off the backs of your ears. I print a lot of toys because my 5-year-old is always like, hey mom, can you print me a boat? Can you print me a dinosaur? So I have a lot of toys and things like that. This is like a little Lego ship, and I apologize. I think the sun is making it where you guys can't see a lot of the details, but there's actually like even writing inscribed. You might be able to see it better on the boat. They all have writing. So the level of detail that's printed on the Sketch, which Pat is going to share a lot more detail about, I've just been incredibly impressed. Got a little canister here, lid screws on and off. These are some of my favorites. I absolutely love the things that are mobile. So this is my little octopus here. They print like this. This is not something that was assembled. It comes off the build plate this way. This is kind of our little unofficial mascot here. This is Sketchy the gecko. So, and then last one, this is my little shark. Once again, as you can tell, I'm really fond of the things with the vertebrae, but his jaw even opens and closes. So clearly, as you can see, they were right. I really enjoyed 3D printing. I've got some more stuff on that little shelf behind me, but I just wanted to bring a few things to share with you guys. So I will pull my screen back up here. Okay. So I mentioned I wanted to go into a little more detail about our student certification. So I mentioned we have the ISTE certified teacher trainings. We also have certification program for students. So with this, they go through operations training on the printer. That's also true on the teacher certifications. They go through operations training on the printer that just helps them feel really empowered and knowledgeable. It's easy to use, but that training is always good to have. And then for our students, they move on to really getting into design iteration and that thinking process between taking their ideas, what is it that I need? What do I want? How do I create it? I'm going to design it. I'm going to print it, bring it to life. And then it becomes, I'm going to test that sample. Is there a problem? How do I make it better? And we kind of continue to go through these different iterations until we end up at a final product. And that design process is something that comes in so handy down the road. So we have one of our customers is Peloton. And you can go and read the success story is online, but they used one of our MakerBot printers to do the prototyping for the knob on the bike. And so it went through this exact same process where there were several iterations of, okay, we've got our initial, we built the file, we sent it to the printer. Okay, we're not crazy about this, or what if this was smaller, or change this side, send it back to the printer. And they went through a few iterations that you can see on that case study until they came up with their final design. And traditionally, before they were using our printer, that was something that was being outsourced and took a lot of time to send that model off, have it printed, it comes back, then they investigate it, make suggestions for change, have to update the model, send it back. And so instead of it taking a few weeks for this process, it took a couple days. So that process is something that is going to cross multiple levels as they continue to move up into higher ed, as they continue to go out into the workforce. And I mentioned I'd also wanted to circle back to our education community. So if you guys are familiar with 3D printing at all, you're probably familiar with Thingiverse. Thingiverse is the world's largest open community platform for 3D print files. What you may not realize is that MakerBot actually owns Thingiverse. We created Thingiverse back before we ever even had our first 3D printer. And we're very passionate about sharing as much of those resources as we can. So within Thingiverse, there is MakerBot Education. There are over 600 ready to go lesson plans. They are aligned to NGSS and Common Core standards and written with the support of over 80 leading STEM educators. So MakerBot is truly very invested in the educational community, and how do we make this as seamless and easy as possible for our educators to start implementing this in their classroom. So we have those trainings, we have those certifications, and we have pre-built lesson plans that are available for them so that they can start implementing right away, before they really may feel confident building their own curriculum. So to kind of touch on the progression as we move from K through 5 into middle school and high school, and where 3D printing is really coming into play and helping hone in on those skills. Through K5, we are just inspiring that curiosity in STEAM, right? We're creating tactical models, complex concepts, and just they're establishing spatial reasoning, getting early engineering concepts, and just really sparking that drive to continue to grow and do more. And then from there, moving into middle school, they really start to develop those design thinking skills. And I am going to share, I won't share all these videos, but the team will have them, and you guys could definitely go back. I encourage you to watch them, but I will share the short video with MacArthur Bar Middle School that really is showing this design iteration in action and how they were using these hands-on engineering principles. And then once we start to get into higher ed, we're really learning professional 3D design skills. There's stimulating real world engineering problems and really getting ready for that college level advanced design thinking. As you guys may or may not know, 3D printing really kind of stepped into the limelight in the midst of this pandemic back in the very beginning. In March, when we weren't able to get a hold of things and PPE equipment was so scarce and no one could get a hold of everything, the ability to print what you needed when you needed it was incredible. And so, a lot of people were 3D printing masks and braces for face shields and all those things. And we saw so many schools and libraries and students who just rushed to help with these efforts. And I think that was so huge for them to be able to see that they were really making a difference and helping to help, just help the situation. So I will click Video. And I know I talk really fast. I know the guys said they would interrupt me, but if there are questions and you guys need to interrupt me, like, please do.
The kids
I
design
don't think I clicked the special button where you guys could hear what was happening, did I? Or maybe I can. Can y'all hear that, Pat?
Oh, we can hear it. We can hear it.
Oh, okay, just
Yep.
kidding. Okay, thank you.
Start from the beginning, Crystal.
Yeah, I'm gonna start it over. There we go.
I'm Vinny Garrison. I teach technology here at A. MacArthur Bar Middle School. I'm teaching the 5th, 6th, 7th, and 8th graders. The kids design a car, they build a car, they race a car. The car is based on weight. So they know if they make the wheels as thin and as light as they can, it's going to be a big advantage. Last year was the first year we started 3D printing wheels. It's doubled kind of the engineering aspect of it, really. They were designing the car and building the car. Well, now they're designing the wheels and building the wheels. For what I do in here is I talk about form and function. You want to make something fast? We're dealing with function. And I'm going to set up the track. Guys, your cars need to be here if you haven't raced, okay? And you guys are up. It's trigger time. Alrighty, guys. Hey, we got 2 cars coming. Heads up.
You guys ready?
3, 2, 1.
Melanie, you are the winner.
Every kid got at least 3 or 4 runs. I would take their best time, and I'd use Excel and put them in order. I started a new list last year, and at the time the record was 0.701, and now it's 0.643. It's 0.05 of a second. It doesn't sound like a long amount of time, but in this it is. I guess they put it together. They really put together the weight to speed. They understood that ratio. Now it's like an arms race in terms of how light, how thin, how much wheel can I leave? You know, it's completely engineering. I have kids engineering parts that don't exist. They're starting from nothing and they're making stuff that they're using. There's going to be things they do here and they're going to get to college and the teacher's going to be like, oh, well, okay, you're good. You know how to do this.
All right, and with that, I'm gonna hand it over to Pat to talk about our printers.
Awesome. Thanks, Crystal. And it's going to be hard to follow everything that Crystal just mentioned. So, but thank you guys, everyone.
I totally took all the exciting parts. I'm not gonna lie. I was like, Pat, I'll do all this exciting intro and you talk about all the nitty gritty.
No problem. So yeah, thanks guys for joining. Yeah, just wanted to kind of go over kind of our product portfolio and kind of what separates us from a lot of competitors out on the market as well too. So we really have a complete lineup of printers that'll take you all the way from early education all the way through higher education and what people will be using in industry. So that's really important kind of to notate for us. So we have, printers like our Sketch Classroom, you can see all the way to the left. Our Replicator Plus, our Method series, which is going to be more for your career technical education, your higher ed, high schools, and then professionals. And then our Z18 is our large format printer. And I'm going to go over a little bit of details kind of each one, kind of where it fits in and what's the importance of using each of the next ones. Next slide, please. Perfect. This also just shows you just kind of the breakdown. So traditionally in the past, 3D printing has been something that has not been affordable to a lot of people. So a little bit about MakerBot too is that we were one of the first companies to make 3D printing accessible to the masses. And as you can see, prices has definitely come down. As far as our Sketch Classroom, this is our 2 printer setup. Not only with the 2 printers, you get teacher certification, student certification, and filament for about $1,800. Our Replicator Plus is about $2,000. Our method, which has 2 different variations, which I'll go over a little bit later on in the presentation, are about $5,000 and $6,500, and our Z18 is $5,500. So the first printer I just want to go over is our Replicator Plus. This has been our best-selling model for the last probably 5 or 6 years that it's been on the market. It's been a workhorse printer that we have, besides education, the commercial space is used as well too. Really kind of what separates this printer apart is that it is our 6th generation of printer. So we've had a lot of iterations on this type of unit. Super easy to use. It has an LCD screen that you can see at the top over here. Everything, you just turn the knob and it's going to tell you exactly how to load your filaments, how to heat up the printer when it needs to heat up the plastic. Super, very intuitive, very easy to use. Along with this printer as well too, you also get 1 copy of our teacher certification program, so that whoever is responsible for implementing it into the classroom is going to be able to get training on how to use the printer, and then also how to teach using 3D printing in the classroom. So as Crystal mentioned, it's going to teach you how to think about ideas of how to implement design thinking into the classroom so that you can use it for your STEAM and STEM courses. And then it also comes with the crash course of our educator's guidebook. So this is about 200 page guidebook that we actually came up with internally. And it's a crash course on 3D printing itself. And then the next part is different design programs and different lesson plans. And it breaks down each step of the way of how to do the project. So it starts with, what are the overall goals of the lesson? Do I have any kind of preparation time before I actually start the project? And then it breaks down every single step of the way of how to actually complete the project and what the goals are. The next thing after that is our Sketch Classroom. So this is our newest printer that we just released as of February as of last year. So this is a great printer setup that we have. As I mentioned before, it comes with the printers along with filament, certifications for teachers and students, and then our MakerBot Cloud software as well too. I'm going to back up as well too and say that all of our printers, even if you have older generations of our printers, can utilize our cloud software. All you have to do is log onto our website with your MakerBot account, and you can actually use the cloud slicing software with your Sketch, your replicator minis, your method Z18. So if you have existing hardware from us, it is also compatible with our MakerBot Cloud software. And besides that, it also comes with those with the MakerBot Education. So it has those 600 lesson plans ready to go. So not just along with Sketch, but if you have any one of our printers, you can go to Thingiverse Education and find all of those projects as well too. And then our other newest printer that we released is our Method for Education. So this printer is really geared towards your high school, your robotics clubs, your career and technical education, higher education, and then as well as professionals as well too. So what we've done is we're actually owned by our parent company is called Stratasys. They actually invented 3D printing FDM technology about 30 plus years ago. So what we've done is we've taken about 30 of their patents, put it inside this Method printer that gives you access to printing that is going to be industrial or available on an industrial scale that you're not going to find on normal desktop printers that you'd find on the market. So kind of what we saw years ago was that there's kind of 2 different systems that you'll find as far as 3D printing. You'll find your desktop systems, which are great. They're very easy to use. They're very accessible. They have a lot of great features, but you're not going to have things that you're going to be able to do print reliably or print that are advanced on your desktop systems. They're not really made for that. And then on the other side of the spectrum, you have your industrial systems, which is our parent company Stratasys has. They're big, huge, bulky machines that you'll find that are usually on like factory floors, or you have to have a dedicated space to. You're not going to be able to put it just on a desktop or a table in your classroom or in a makerspace. And really the main thing with them is that they can do a lot more advanced functioning, but they're at such a high price point that most people can't afford them. And what we've done is we've kind of combined the Method to integrate all those features from the desktop and the industrial systems to make it accessible for educators so that they can get the best of both worlds. And this is just going to go over some of the features of kind of what makes it unique. And if for anyone who has 3D printers, this will kind of make a little bit more sense. So if you guys have questions, please put them in the chat box, or you can stop me at any time as well too. And I can kind of explain what the differences and advantages are going to be for having this type of printer. So the first thing is the circulated heated chamber inside of the Method. So really what this does, and I'm sure a lot of you know, most of the printers on the market currently have a heated build plate, which is good for the first couple of layers when you actually print your model. So what happens is that you can see on this bottom picture to the left here is that once it starts getting further away from the build plate, the material that you're printing with is not going to stick and it's going to delaminate. What the circulated heated chamber does is that it allows you to control the entire 3D printing environment throughout your entire print. So what that means is that you're going to have a stronger part. You're going to have a much better looking part. So your surface finish quality is going to be much better. And overall, it's just going to be a better print, and it's going to make your reliability increase every time that you print when using with the circulated heated chamber. So this slide is, I like this slide. It's pretty cool. Is that this just shows some of the advantages of having the circulated heated chamber and the other features that I'm going to say. So as you can see on the left here, this is a typical bearing that we're trying to fit inside here. On the method, as you can see to the right, it strictly fits into place. Whereas on the left, they're comparing it to a competitor printer, that has similar features, but it doesn't exactly fit inside of there. And a lot of that is because of the advanced industrial features that you will find inside of the method that you're able to do this, unlike competitor desktop 3D printers. The next thing that also separates the method as far as from different is the extruders as well too. So what you'll find is that inside of these extruders, we've elongated the thermal core inside of it. So what that allows you to do is print 3 times faster than a normal desktop printer because it has no material. It's able to fit more material inside of it. Besides that, it also has a 19:1 dual drive gear ratio. So it's able to have more torque that fits inside of there. And then also the benefit is that it has 2 extruders. So the benefits of having 2 extruders for 3D printing is that the first extruder is going to print your model material. So whether that's PLA, ABS, tough, PETG, ASA, nylon carbon fiber, that's going to be what the first extruder is for. The second one is going to be for the model material, or for the support material, excuse me. So this is really important, especially when you get up to your career and technical education, your high school, where you're making more complex objects. So the benefit of having this other extruder is that traditionally on other desktop printers, you have to orient that part so that it actually can either print with support material that's made with the model material. So if any of you have single extrusion printers, you know that it can be such a painful process to use to remove support material. With the support material like PVA and SR30, you simply just dunk it either in water, which is great for PVA, and then SR30 requires a special wash tank in order to dissolve it because it's used with chemicals. But what it allows you to do is get access to unlimited geometries when actually printing. So you don't have to limit your parts specifically to how it's going to be able to print with support. So it's a huge benefit when you have that second extruder so that you can print more complex parts. And as you can see here, this is kind of what a part looks like when you print it on there. On the build plate here, you can kind of see it looks almost like an Elmer's glue type of material on there. It's kind of like yellowish, like white on there. So all of that the printer does with that second extruder is that it fills in the holes and gaps that you can see on the actual mechanical gripper part. Just fills in that material, and then all that you do is you submerge that in a tank of water for a couple of hours, and then it actually dissolves away that material, and then you get a functioning working part as soon as you take it right out of the water. And then kind of as I mentioned before too, our method and Method X have 2 variations. The difference between them is going to be the chamber temperature that you can actually print with. So a lot of the materials that you can see on here are more lower temperature materials. And then on the bottom is the higher temperature material. So the method can get up to 60 degrees Celsius. So that allows you to print with materials such as nylon carbon fiber, tough, regular nylon, PETG, PVA, PLA, PETSG, carbon fiber, so and some composites that you can do with the mix of the regular model materials. Now on the Method X, it can go up to 110 degrees Celsius. So that means that you can print more engineering and advanced grade materials such as ABS, ASA, polycarbonate ABS. We have a fire resistant version of that, SR30, and then also different kinds of composites that you can print with that as well too. Great. And then kind of as we mentioned before too, that kind of goes over all of our different kind of models that we have too. Now I just wanted to go over briefly kind of the benefits of our cloud software as well too. So I'm not sure if how many of you guys are in classroom versus remote, but we released this feature when we released the Sketch, which allows teachers and students to actually do things remotely, which has been a huge benefit, not only in the education space, but also in the commercial industry. We've seen that people have been working from home. They've had their printers at home, or they've had them at their workplace of where they can design things in CAD, send it to their printer remotely. So as I mentioned, the best way to easily test this software is to go onto our website. If you already have one of our printers, it's just your login to your MakerBot account on our website. From there, you can, you want to go to the next slide, Crystal, then we'll come back to this one. So it has a wide variety of features. So this is kind of what the home screen is going to look like. So the first thing you're going to do is you're going to have your printer button to the left over here. You're going to have your printer's network down here. And then what this allows you to do is that if you have more than one printer, or if you have multiple projects, it's going to allow you to manage your projects and printers. So say, for example, if I'm a teacher and I have 30 students, I have 30 projects that I have to submit. If I have one or two printers, I can queue everything up in the software here, just so that it makes it easier that you can manage all that. So what it's going to allow you to do is that if I have 10 files, I can queue them up to the next available printer, so that it makes it easier for you to manage all the projects that you have to complete. And then also, if you click on the button below it too, is that you can actually remotely check in on the printer. So all of our printers have cameras built on board so that you can watch and check in on them. Also, this will send you notifications if anything goes wrong. And then also, besides the printer management, it also provide analytics too. So it'll show you what your success rate is on the printers that you have, and then you'll be able to check in on all the statistics for all the units that you have. And lastly, the other thing that separates us apart too is that we have the best industry-leading support team. If any customer has any questions or needs to get back up and running, we encourage them to reach out to our support team. They're actually located in our headquarters here in Brooklyn, New York. They only work with MakerBot products. So you're only going to be talking to people who know MakerBot products inside and out. You can create a case online. You can call in and talk to people, and they're going to make sure that you get up and running and get the best possible service that we're able to offer.
Hey, Patrick and Crystal, kind of a question came up. I just want, maybe you can take it before you keep going here a little bit.
Yeah.
Someone asked, what are the resources offered for the students? I understand teachers will receive certification, have access to the projects, but is there a platform the students can access the projects in a more self-guided way? So I'm thinking that's, how would you respond to that?
They actually,
similar to-
the students do have access to the curriculum as well.
They do.
Yeah,
But
if you have that MakerBot login, would get them access, and they can have a MakerBot login.
So would they be able to share projects that other kids have built and teachers from other, or you have to go to Thingiverse for that?
So Thingiverse is honestly, it kind of, I mean,
Thingiverse.
with MakerBot Education, it's more the curriculum piece, right? It's definitely the, what are we trying to accomplish here? Like it's, you know, it's a bigger picture. But the thing about Thingiverse that's really cool in general is that you can go on to Thingiverse and download a 3D printed file. So I'll give you an example. My little ear saver here.
Yep.
This one has a little, you probably can't see it, the glare is bad, but it has a little like anti-COVID symbol.
Yep.
A little COVID sign, and it's like got it crossed through. Well, my husband is an essential worker. He works for Target. And he was like, could you make some of these for my team in red with the Target bullseye instead of the COVID logo?
Right.
So this was a design that I got off Thingiverse. I downloaded off Thingiverse to my computer. I opened it up in my CAD software. And from there, I was able to put the Target symbol over and replace this. And then I can print out my new design. Well, Thingiverse actually very much so encourages people like, hey, you went and you got a design. You give credit to the original designer. But
Right.
then I can upload the new one that I made that's for Target, and it's called a remix. And so it's very much a community of, and it encourages, students to go on there, find something that interests them. Hey, somebody had this idea and this is great. I need it to do this for me specifically, or this is what I want at my desk.
Right.
And they can reiterate on that design.
So Crystal, give me an example. Let's say, and this is something we build with MakerBot, right? It's just an example, right? But let's say I'm in the science, and and I wanted to see a hydrogen atom, or what does water consist of, like the molecules? You know how I've seen them with the balls kind of put together. Where would they go to do that? Is there, say I'm a kid and I want to try to play around with a 3D printer and support my science, my biology or chemistry in that case.
So there may very well be something on Thingiverse
Right.
that's already there, but if there wasn't, a lot of our schools are using free CAD software, right? MakerBot, we don't have our own CAD software, but there are a ton of different programs out there. And I mean, it just off the top of my head, if I'm the student and I want to create this molecule, like maybe there's not a 3D file already, but I can take a 2D file, convert it to a 3D image, and then upload it into my CAD software and mess with it from there to get my print to be what I wanted it to be.
So the example, just using the one that I'm common with, Tinkercad is a common 3D. So they could go online, get access to Tinkercad, the free CADs, the teacher can help them. And then basically they could design a module or a molecule of chemistry and then send it to the MakerBot to be printed. They wouldn't have to worry about slicing and all that. The MakerBot would take care of that, correct?
Yep. And we have a direct plugin with Tinkercad as well, too. So they're one of our partners that we work with is Autodesk. So it's super easy to integrate with them. If you already use Tinkercad, you can literally export right to your MakerBot right from Tinkercad, which makes it super easy for them. And also I wanted to mention too, besides that, we also do offer design challenges for students as well, too. We just did one, what was that, at the end of the year, Crystal, so that we come up with concepts that students can be engaged as well, too. So we had our last one that we just did at the end of the year was students had to design their own workplace space saver thing that they had to create. So students actually went in and created their own things. And we had judges of people that, graded their designs of what they actually created. And the great part about it too, is that you don't even need a 3D printer to actually participate in that. As long as you have CAD software, you can participate in as well too. So it's just, 3D printing is just the next step in the process so that you actually get the actual model that you print.
So to summarize, and maybe because I'm always thick, so they could go and use something that's on Thingiverse, correct? Like a model that's already created, or they could go out onto the, and find some free software CAD solution like Tinkercad, or they could leverage something they already have in the school system that's a paid 3D solution, or they can use your education stuff, in your curriculum and stuff like that to kind of give ideas and things like that, correct?
Yep.
Perfect. Great. I'm sorry to.
No, I think that was pretty much all from us. So if there are any other questions.
Okay. Other questions out there? I mean, one of the things we've seen, 3D printers have been great this year. I mean, previous in 2020, people have used them for PPE. We got actually a college the other day called. They had a unique application for 3D printers. They were thinking of taking and showing kids the different types of seeds in the world, and basically printing them on the 3D printer so kids could see what does a corn seed look like, what does a rhododendron, and all these different types of seeds, and explaining, cutting the seed so they could see the inside and the different pieces of it that make up a seed, which we thought was really interesting. So, yeah, very cool area. Any other questions? I'm just looking. I'm sorry, Patrick, I cut you off.
I was going to say, we have a lot of cool examples of like that too, of like people actually printed out, animal and plant cells as well too, that they actually printed out. So 3D printing is not just also about, obviously we want students to be able to design their own things too, but it's a great visual aid to actually print out things that you can show your students that you might not be able to do in a textbook or right on the screen. So it's a great visual aid that you can use to incorporate in the classroom too, because there's a lot of students out there that are much better visual learners. So that's another aspect that we see. It's a different way of teaching and thinking about education.
Definitely. And I think that, the industry has evolved, because I would admit that probably 4 or 5 years ago, 3D printing, was kind of a little more limited, it was kind of very technical. the one reason we love the MakerBot is that it's a complete turnkey system. You're open to choose your 3D package of design, and then you take it away from there and you make it so easy. And especially with the classroom software you just talked about, being able to remote print, whether the teacher has the printer in he or she's house, in a classroom or someplace else, their garage, and being able to kind of do some different types of design, which we think is great.
And we can talk about that super specifically, but I mean, I know where I am, we have a lot of hybrid, right? Or they're going into the classroom one day a week or, whatnot. So in those respects, right, if the printer can be there and they can go in one day a week, like to Pat's point, the actual designing piece, like the 3D printer is just the piece that brings it to life, but the CAD software is free. They can do it from home. And with CloudPrint, they can submit those files through Google Classroom, through our CloudPrint to their teacher. And so they could still get that project, I mean, if they're completely remote, we've had teachers printing them off and then doing same thing I did and showing them their file or shipping it to them. But if they're going in the classroom, that one day a week, they could be submitting their file on Monday and then picking it up when they're actually in the classroom on Friday.
Yeah, no, I think the fact your software is tied into Google, Google Classroom, and the fact you could do what you just talked about is having a teacher be wherever and have the kids submit their, into a queue, is just fantastic. It makes it easy, or send it to them, which is great. So, all right, any other last minute questions? If not, we want to thank everybody for attending. We will send a copy of this presentation out. We'll get that from Crystal. And if they have any other documents, we'll put it in a blog post that'll have that. So you can get a copy of the webinar, a copy of the presentation, and any other documents that we feel free. If there's any other questions, if not, we'll give you back some time. And we want to thank you very much for attending today. As always, I learn a little bit more about different technologies. So thank you very much. I want to thank Crystal. I want to thank Pat, and I want to thank everybody else for attending. I know it's very difficult to find the time. So have a great day, and I look forward to a safe and happy 2021. Thank you.
Bye, guys. Thank you.
Bye-bye.